Hi, welcome back to Andy's Alien Space Education. Um, we're on a brilliant new season here, so I really hope you're enjoying it. Today we're looking at the many types of stars. Now, there's lots of different stars that we have in our universe, including what you may think our sun is a star, and it's a lot smaller than you think. So we're going to get into all different things. Please remember to like, share, contact your friends, let them know that this is going on, and I really hope you enjoy these. So, getting on, we've got the main types of stars from small to massive. So, let's start with the main categories of stars based on their mass, size, and temperature. That's how we measure them. So, first up, we have red dwarfs. These are small stars and the coolest type of stars, burning in a faint red glow. Red dwarfs are incredibly common in the universe. In fact, most stars in our galaxy are red dwarfs. Although some although they're very small and dim, they are also incredibly long-lived, with lifespans that can stretch into trillions of years. This longevity makes them increasingly interesting candidates in search for planets that could harbour life because you've got to think these stars are small, but they're still really, really hot. And the red ones, you think it's not like hot and cold water where you look at the red tap and that's hot and the blue one is cold. Stars are the opposite way around. The red ones are cold and the blue ones are hot. So we'll get more into that as we go on. So you've got to think these stars, if they're producing light, they're producing heat, and we can see that. That means if there's planets around them, which there more likely is, there's likely to be life. So there's a good chance that we can find life around red dwarfs. Okay, so we have yellow dwarf planets. Now these are, well, the easiest way to say it, like our sun. Yellow dwarfs are warmer. They're more massive than red dwarfs, but are still relatively stable in what they do. These stars, part of part of what we know as the main sequence, burn hydrogen steadily for billions of years. So a very long time. Not like trillions, we're talking billions. So a little step down. Providing a steady light and heat. This stability is crucial as given planets in the habitable zone a chance to develop life. So we are incredibly lucky that our star, our sun, our soul, was able to do this. And we were lucky enough that our planet just happened to be in the habitable zone and we now exist. So yellow dwarfs are, there could be life like us out there around a yellow dwarf. But who knows how life will change from planet to planet to sun to sun. The next ones are the blue giants. Now, these are hotter, so much more hotter, more massive, and right at the very end of the spectrum. These stars are incredibly bright, have a much shorter lifespan than other types. They burn through their nuclear fuel at a rapid rate, meaning they only last a few million years. So you can see how we've gone down from trillions to a good few trillions to billions, now down to millions of years. In a blink of an eye, in cosmic terms, these stars die. They often go up with a big bang, ending in spectacular supernova explosions. And these supernova explosions are so big we can actually see them. And we can see the nebula and everything afterwards. So we are really trying to find more of these. We haven't witnessed one yet, and we're hoping to witness one soon. But these are things we're looking at. However, this isn't the only type of stars. The next type we have are called supergiants. Now, these are really, 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 really big stars. These are among the largest and brightest stars in the universe. They shine with incredible intensity. Betelgeuse, as you know, is going to go supernova in the next 2 years to next 2 months to 10,000 years. We honestly don't know, but we think it will go supernova. It is a super red giant in a constellation of Orion, is well known, and it's massive enough that when it ends in its supernova, it will leave behind either a black hole or a neutron star. And I'll cover those later on, so please don't worry. Now so when Betelgeuse does go supernova, if you know where Orion's belt is, it's easy to spot 3 little stars across and go slightly above it. That is Betelgeuse. That star will go boom, and hopefully we'll be alive to see that. It won't wipe us out. Don't worry, it's millions and millions and millions of light years away. So don't worry, it's a few light years away, so it's going to take a long time for us to see it. But it will mean that for a short period, we will have 2 bright dots in the sky, one the sun and Betelgeuse, and that could last up to 2 years. We will see that Betelgeuse explosion. Who knows? It might be less, it might be long. We don't know, but we'll soon. In addition to the main types of stars, there are some unique stars that don't fit into these categories. For example, white dwarfs. Ooh. What are remains of medium-sized stars like our sun. They reach the end of life after shredding the outer layer of the stars. The stars cool down, shrinks into a hot little dense object about the size of Earth. Although they no longer go fusion, white dwarfs glow faintly as they cool down over billions of years. So white dwarfs are cooling down. So you think when you burn something, it gets really, really hot, it gets whiter and brighter. When stars, it gets whiter as it begins to cool. So stars are doing the opposite to how we know things here on Earth. That's really fascinating, really fun. As I mentioned before, neutron stars, they are formed from the collapsed core of a massive star after a supernova. Neutron stars are unimaginably dense. A single teaspoon, a tiny teaspoon of a neutron star material would weigh about 4 billion tons. That's a lot to weigh in one little teaspoon. I wouldn't be able to lift that. I don't think you could either. Some neutron stars rotate, so they're still spinning super, super fast, rotate rapidly, emitting beams of radiation impulses, and we call these pulsars, and they act almost like cosmic lighthouses, sending out regular signals that astronomers like us can detect, and we can use them to measure how far away they are, what's happening around them, if anything moves around them as well to indicate how much they wobble. So we use neutron stars amazingly now to help us map the universe. So neutron stars are fascinating for 2 reasons. So heavy, so small, so heavy, but they help us map the universe. And then we have binary stars, and depending on how you look at it, multiple star systems where 2 or more stars orbit a common central mass. Now, binary stars are common in the universe, and their interactions fascinating effects, especially if one star in the system becomes a white dwarf or a neutron star. Now, binary star systems or multiple star systems are when you have 2 stars and they orbit each other. Like we say, Jupiter is a failed star because it wasn't big enough, it wasn't heavy enough, it never got the hydrogen to ignite into never got the mass to ignite into a star, which thank God it didn't, because we wouldn't be here if it did. But a binary star system where two stars circle each other, if one goes, what happens to the other one? That's the question. That's what we're looking at. That's how we do it. But if one turns into a black hole, we see the other one get poured into a black hole, and we see that amazing effect. So we have seen some things that we think have happened to one star, not the other. But what happens if they both go at the same time? That we have not seen, and that we don't know what's going to happen. But it'd be interesting to find out. Maybe with your telescopes, and you study really, really hard, you can help us find these answers. So it's really, really cool that we're looking at these things and seeing how these things happen. So stars are brilliant to look up at. Right. So now we're going to look at some rare, exotic type of stars. Let's talk about some of these. But these stand out. So these ones you could be able to spot. So Wolf-Rayet stars, these are unique types of massive stars with intense winds that strip away their outer layers, exposing their hot, bright cores. These stars are incredibly luminous, bright, and can lose a significant amount of their mass over time. Because they are so massive, Wolf-Rayet stars often explode as supernovas and may or may not, but most of them do, leave behind black holes. So a star that leaves a black hole more likely be a Wolf-Rayet star, but we need to measure them and monitor them to see which way it's going to go. There are also mysterious magnetars. Now, they're a type of neutron star with extremely powerful magnetic fields. Now, we're billions of miles away, a few light years away. How do we know they're magnetic fields? These magnetic fields are so strong that they can cause starquakes on the surface, releasing bursts of X-rays and gamma rays, which we can monitor here. So they reach us here so we can see what's going on back there. It may have happened in the past because obviously a light year away means it's taken a year to reach us, but we can monitor that. Magnetars are incredibly rare, and only about 30 are known in the Milky Way galaxy, which is where we live. The Milky Way galaxy. There could be more out there in other galaxies and in the universe, but we've only discovered 30 in our home galaxy. That's really cool. 30 of these magnetars. Hopefully, maybe you can help us find some more. Finally, we have hypergiants, some of the largest and most luminous stars in existence. These are massive, hundreds of times more massive than our sun. They live fast but die young. So the bigger they are, the shorter the lifespan. Usually explode into a hypernova, which means they are even more powerful than a regular supernova. So a hypernova, wow, that's got to be really powerful. These stars are so rare that only a few have been observed, and they are critical for understanding the extreme end of a stellar life cycle. So by monitoring these, we can see how stars live, how they die, what will happen in a hypernova, and say, right, that happens in a hypernova, what happens in a supernova? We can use the data to correlate between the two. So we're looking at these things and we're trying to learn more all the time. And this is what makes astronomy and looking up at the stars so amazing, so much fun, because we're discovering things about ourselves, about the sun, that we never thought we'd know. And that by looking further afield, we're able to learn more about what's here. Hypergiants, magnetars, Wolf-Rayet stars are some of the universe's most energetic and short-lived stars. They play a huge role in enriching galaxies with heavy elements. So when stars go supernova, remember, all that material will blend together and make new heavy elements. When they explode, they release material to become part of the future stars, planets, and even life. So you've got to think that the stars dying helps us create life. It helped create life here. So what life has it created elsewhere in the universe? So that's why we need to study it. So big stars are just as important as our tiny little sun. And it's really good that we do look at these and learn about them. So why is diversity of stellar types? So why does this diverse star types matter? Each type of star plays a significant role in the galaxy. Red dwarfs provide stability over long timescales, making them potential homes for life. Supergiants and blue giants release heavy elements through supernovas, enriching interstellar and medium, providing building blocks for new planets. Because you've got to think, when a planet is formed, it collects material around it, it sucks it all in under gravity, and that could be from other stars and everything like that. The more we understand about different types of stars, the more we learn about the life cycle of the matter in the universe. Not just the matter here on Earth, not just the matter that's out in space, but the matter in the universe, the wider thing. And every atom in our bodies was forged in a star. which makes the study of stars deeply connected to the origins of life ourselves. We are star stuff. It helped create us. So by understanding stars, helps us understand us. Helps us understand how life was formed, where the heavy elements we dig in the ground for, where they come from, and the new materials we're coming up from. Maybe they're already made out there. We just haven't discovered them yet. I'll say that's a wrap for today at the minute. Let's wrap up this exploration of the many types of stars, from tiny dwarfs to explosive supergiants. Each star has a unique story that contributes to the tapestry of the cosmos. Thank you for tuning in to Alien Space Education. Join us next time as we look into what have we got. We're going into the life cycles of stars. It's going to be fun. Keep listening and keep sharing and enjoying. Thank you.